solving trig equations with technology. We've kind of covered this topic already in different ways, so we'll start with a basic review of solving some algebraic expressions with technology. So the first one is a question from grade 10, quadratic. So you've got x squared equals x plus 2. We can solve this by using algebra without a calculator at all. And whenever you have a squared term, we're going to make everything equal to 0. So just move everything on one side, and then factor. So find two numbers that multiply to negative 2 and add to negative 1. That would be negative 2 and positive 1. And then we can find the solutions to both of those expressions. So there's two possible answers. Normally we check our answers, but we can't have any extraneous roots in this case. So the other possibility is you can solve this with your graphing calculator. So if you take your calculator and graph both sides of an equation, this works for any algebraic expression or trig expression. You can graph x squared along with x plus 2 and find out where those two graphs cross. Okay, so just using a standard window, you can sketch this onto your page. We have the graph of x squared, which is a parabola, and x plus 2, straight line, and those cross at 2 points. Which is when x is negative 1 and when close, enter, 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 x is 2. So that's using a basic standard window from negative 10 to 10, negative 10 to 10 for y. Now you can also put everything onto one side and find out when it's equal to 0. So just like we did in this equation, just move all of the positive terms to the other side and find the zeros. So if instead we graph x squared minus x minus 2, then we see that it crosses at 2 points. Negative 1 and positive 2, and you can see that directly on the graph. Now there's advantages and disadvantages to both the ways. If you actually want to calculate the zeros in this case, it's quite onerous. You have to go second trace, choose number 2, 0, and then you have to choose a left bound. So you have to enter to the left, and then you have to go to the right of the 0, and enter to the right, and then hit enter for a guess, and then it will give you the 0. So finding zeros is difficult because you have to do a left bound and a right bound. Now I know what some of you do is you go to the y equals and you hit 0 here. And if you graph both sides, so you can graph like this stuff, and if you want to find out where it's equal to 0, just put in the term 0, and then you can find out where those two lines cross. You can do intersect instead of having to calculate 0. Okay, so the good thing about having the zeros is that you always know that your answers are going to be along the x-axis. The trouble with graphing both sides of the equation is sometimes your answers might be like way up there in like the 10,000s, and you'll have to keep adjusting your window to make sure you found all the answers. Where at least with the zeros, you can like just look at the x-axis and just look for crossing points. You don't have to worry as much about your window. Okay, so that's the advantages and disadvantages of each method. Any questions? Okay, so now we'll apply this to trig. But first, a little review of period. So if you have sine 2x, what's the period? Hi, it's compressed 2 times. So instead of having a period of 2 pi, if we compress it 2 times smaller, then the period becomes half as big. Cosine of half x is an expansion. So what is the period of cosine half x? 4 pi. 2 pi divided by a half. Divided by a half is 4. Okay, 2 times as big as normal. Sine of pi x. This one has been compressed by a factor of pi. It's what? 2. And the most difficult one. Pi over 3, not 2/3 pi. Tangent has a normal period of pi. So tangent's normal period is pi, so for tangent, the equation is pi over b. So the equation is p equals pi over b. This equation is for tangent or cotangent. So the reason why we have 2 pi over b is really its normal period divided by b. But tangent's normal period is pi, so we do pi over b instead of 2 pi over b. So this period is pi over 3. You can also graph that to see how long it takes to repeat. Now, a trig equation is a trig function that has some variable inside of the trigonometric function. So if you have an x inside of your cosine or sine or tangent, then this is a trigonometric function or equation. What about the second one? No. Tan of pi is just a number. Tan of pi over 3 is also a number. The x is not inside a cosine or a sine. So this is not a trig function. Which other one is a trig function? C. C has an x inside of the sine, but D does not. This is just a number. So this one is not a trig function. So now we get into the trigonometry. Can we solve sine of x equals 0.79 to 4 decimal places if we have a domain from 0 to 2 pi? So all we have to do is graph both sides of the equation. We're going to graph y equals sine x, and we're going to graph y equals 0.79. Make sure that your calculator is in radian mode for all graphing problems when you're using sine and cosine. So we'll put sine x and 0.79. And make sure the mode is radians. And then you can choose zoom trig. Okay, so the solution is the x-coordinates of the crossing points. So here I've got my graph from negative 2 pi to 2 pi. My y goes from negative 4 to 4. That's the standard trig window. And I get my sine graph, which starts in the middle going up and does one complete rotation. And there's my line 0.79. How many answers are there? 4 in this window. Now, the question is saying that the domain is 0 to 2 pi. So what that means is I only want to look for the answers when x is between 0 and 2 pi. I only want the answers here. So how many answers are there from 0 to 2 pi? 2. There's 2 crossing points. So here's 0, here's 2 pi. So let's find out those crossing points. Calculate intersection, enter, enter, enter. X is 0.9108. calculate intersection, go close to the answer, enter, enter, enter. X is 2.2308. So now what does that mean on the unit circle? What are these X things anyways? Are they ratios? They're probably something pi. Yeah. So one thing that you can do is you could quit and take your answer, which actually if you push the letter X in your normal window, then it actually has the answer there. It's amazing. And if you want, what you can do is you can divide out pi and then see if you get a fraction left over. And you can try to change that to a fraction. It doesn't really change. Okay? It's only going to change to a fraction if this is something nice like root 2 over 2 or, you know, 1 over root 3 over 2 or something nice like that. But 0.79, it doesn't actually equal anything pretty pi. It's 0.71 pi, which is, where is that? 0.71 pi, 7 pi over 10. Somewhere in here. Oh no, that's later. Sorry, this one is 0.9108. These two things represent angles. Okay, so 0.9108 is just somewhere less than pi over 2. This is pi over 2 up here. So let me check. Pi over 2 is 1.57. So it's a little bit less than 1.57. Well, where is 2.23 on the unit circle? Do you know which quadrant? All students take calculus. Sign is positive. Quadrant 1 and 2. So this answer is actually in quadrant 2, right here. Okay, and that's an angle from the beginning to here. The angle is 2.2308, a little bit bigger than 1.57. Okay, if you remember from before, you can actually see the 4 quadrants on a graph. This is quadrant 1, 2, 3, and 4. Okay, and actually these will pretty much make a triangle that is 3, 4, 5. Because if this is the angle, x, it's saying that sine x equals opposite over hypotenuse. 4 over 5 is 0.8. Okay, so if you have a 3, 4, 5 triangle, then the angle is 0.9108 radians. Okay, that's approximately. Because 0.79 is pretty close to 0.8. Are there any questions? That's how the two are related, the unit circle, the triangles, and the graph. So now on the back side, we want to know, what if we weren't looking at the domain from 0 to 2 pi? What if we're looking everywhere? So suppose that the domain is all the real numbers, which means that, suppose that we're looking at the whole graph of sine forever and ever and ever. How many answers would there be? Infinity. Okay, so what we can do is we can take the first answer, 0.9108, and we can add the period. n times. Do you know what the period is? 2 pi. Okay, so if we add the period 1 time, then we get to this point here. And if we add the period 2 times, then we get to this point here. And we have to say that n is an integer. If we subtract the period, we would get to this point. So then we also need these points. So we'll start with our basic. This one was 2.2308. So we can say x is 2.2308. And then we can add the period as many times as we want to. Where this would be if n is 1, if n is 2, if n is -1. We would get all the other points on the graph forever and ever and ever. Okay, so we're just taking the period n times. So that would be called the general solution. Okay, does that make sense? So now we have a very complicated expression. You would never want to try to solve something like this by hand. We're given 2 sides of an equation. So you can just take the 2 sides and graph them. And find out where those 2 lines cross. So the first part says find out what is the answers from 0 to 2 pi. So that's just for one period, or sorry, for one normal period. And then find the general solution. The general solution is when you add the period n times. So just give us a try and see if you can find out the 2-part answer. Okay, so to solve this, you plug in both sides of the equation. And you can use your Zoom as Zoom Trig. The nice thing about Zoom Trig is it automatically goes to 2 pi. Brody? So the window's not quite good enough to see the whole graph, so I'm going to increase my y value a little bit to maybe 6, so that at least I can see the top of the graph. There we go. And you can see it crosses 1, 2, 3, 4, 5, 6 times. So we've got one graph, 2, 3, and the other graph going like this. So we've got 1, 2, 3, 4, 5, 6 answers from 0 to 2 pi. So you calculate the intersection. And you get x equals 0.59. I'm going to use a few fewer decimal places in this case. Now, I can put in, I can use second intersect, calculate intersect over and over and over to find the rest of the 6 answers. And I'm sure that you guys did that already, right? So now let's check it in another way. If I hit x, I get the first answer. To get the second answer, I can just add the period. The period is not 2 pi, but 2 pi over 3 because it's been compressed 3 times. So if I add 2 pi over 3, I should get one of the other answers, and you guys can check that. Is 2.68 one of the other answers? That should be this one right here. And then I can do that again. 2 pi over 3, and I should get another answer, 4.78. And that should be this answer here. And now I can do the right side of the bumps. So let me calculate intersect the right side of the first maximum. And it's 1.5. So to find the next answer, I can take my x and I can add 2 pi over 3. And it gives me 3.6. Is that really one of the other answers? Fantastic. And then I just hit enter again and it'll give me another one, 5.7. I can actually go enter, 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 and it gives me all the answers to infinity. Okay, so there's my 6 answers from 0 to 2 pi. For the general solution, what do I add? 2 pi n. 0.59. Is it 2 pi over 3, right? The period of these graphs is both 2 pi over 3. So instead of 2 pi n, I'm doing 2 pi over 3n. Okay, because I have the 3 in front of the x. Now, do I need any other parts for the general solution? Yeah, I need to use another answer, starting with 1.5. Okay, I need to also do these points here. So the red ones would be the right side, the black ones would be the left side. I don't have to list 2.69 plus 2/3 pi n because that's already in the black. Okay, so all these ones are all in the red equation, and all the top ones are all in the black equation. Are there any questions? And this crazy symbol here just means that n is an integer. N is in the set of integers, which means negative or positive numbers. Okay, so another example, we have 2 sides of an equation here, so we can graph both sides. But this one's kind of tricky because it has this squared thing. So I'm going to graph 0 as the other side, so I don't have to find the zeros. When you see cosine squared x, what you need to know is that this means that cosine x is all squared. Okay, and the reason why we write the squared there right after the s is because we don't want to get mixed up between cosine x squared, which means that only the x is squared. So when you see cosine squared x, that means the whole expression is squared. So in order to type that into your calculator, you go to your y equals, we'll go 3 cosine x, and then all of that is squared. Plus 4 cosine x minus 4. Find out when is that equal to 0. Wow, that's really quite far down. I'm going to have to change my window a bit. So I want to go all the way down to maybe -8. Oh, look at how cool that is. It has a little itty-bitty local maximum down there. So take a look at the equation again. Okay, so we're squaring the whole cosine x function. Not squaring just the x, but squaring all of cosine. How many zeros does that have from 0 to 2 pi? 2. Okay, from in this portion here, we can see it crosses the x-axis 2 times. So really, we're interested in what's happening in this section here from 0 to 2 pi. go from negative 8 to 6 here. So I can calculate where does that cross, number 5, enter, 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 and I get, oh, it's thinking so hard, x equals 0.84. We're going to do more expressions like this next class that have squared term. We can solve these ones algebraically as well. We get 5.44. Okay, so the solutions are x equals 0.84 or 5.44. So that's the solution from 0 to 2 pi. So the general solution, what do we have to add to those numbers? 2 pi. And you can kind of see that in the picture as well, that after 2 pi, after one of these half windows, the pattern repeats. So we're going to add 2 pi n to both of the answers, and that'll help us to get the rest of the answers on this side. So this would be when n is negative 1, the next one would be n is negative 2, and so on. So we say n is an integer. It helps to be able to recognize some decimal approximations of common radian measures. And especially something like pi over 2. This one comes up a lot. So why do so many trig equations have an infinite number of solutions? Whenever we did polynomials, we only had like 1 or 2 answers, or maximum 6 maybe. And now we're having so many. Why is that? Yeah, it goes infinitely from side to side instead of just infinitely upwards or downwards. They repeat. Because they have that period, that repetition. How can you reduce or limit the number of solutions so you don't have to say them all? Limit the domain. And that's why a lot of questions will ask you, what's the answers from 0 to 2 pi? So that you don't have to say all the millions and infinitely many solutions. So your homework for today is from page 281, numbers 1 to 4.